All right, Algebra 2, what's up? Here we are with 13.4, day 1, double angle and half angle identities. All right, double angle identities, the following hold true for all values of theta. Sine of 2 theta, or the double of your angle theta, is equal to 2 times sine of theta times cosine of theta. Notice the difference here between the 2 theta and the theta theta. Okay, cosine has a variety of formulas or identities to use, and you can pick the one that suits you the best for whatever situation you're in. Cosine 2 theta equals cosine squared of theta minus sine squared of theta, 2 times cosine squared theta minus 1, 1 minus 2 sine squared theta. Okay, so that's probably the main one here, but you might not always easily know what cosine and or sine are. You might only have one of them. Okay, and then these other two are found from substituting in your previous identities into cosine squared and sine squared. Tangent 2 theta is 2 times tangent of theta over 1 minus tan squared of theta. Half angles. Sine of half of theta, theta over 2 is plus minus, depending on where you're going to be at, of square root 1 minus cosine theta over 2. Notice the over 2 is inside the square root. Cosine of half angle theta is plus or minus. Again, plus or minus depends on where you're at. You'll have to do a little thinking. The double angle ones, it works out fine. Don't have to think about it. The half angle ones, you have to think about because you're doing a square root, so you need to know if it's the positive or the negative. And then, so we had square root of 1 plus cosine over theta over 2. And for the tangent one, it's 1 minus cosine over 1 plus cosine. And you could kind of come up with that, sine over cosine. Okay, so let's do it. Let's do it. We're going to just be solving here. Then the day 2 is more of the like identities and proving it stuff. Okay, these take up a lot of space, so you can either write small or you might need a separate piece of paper for notes today. The very first one, we're going to do all 4, and then after that, we're just going to do like half. We'll either do the double angles or the half angles, so we're not going to do all 4 for each one. It's going to be really, I'm not good at writing small, you know that. So we'll see where it goes from there. All right, cosine of theta equals negative 5/13, and we are pi over 2 to pi. That's quadrant 2. So just a quick sketch here. We're in quadrant 2. All right, cosine is negative 5/13. So think back to what cosine is. Adjacent over hypotenuse, negative 5. Hypotenuse is 13. We need to know what this spot is. Okay, a little a squared plus b squared equals c squared. Plus b squared equals 13 squared. 25. B squared equals 169. Subtract that over 144. Square root is 12. All right, and sine is positive, so it's going to be a positive 12. Okay? Negative 5 here, because it's backwards negative. It's backwards 5, so our cosine's negative, so I put the negative on that 5. Okay, find cosine of 2 theta. Nope, and sine of 2 theta, sine of half, and cosine of half. So this isn't just like, oh, I can use my right triangle and be done. You're going to actually have to use your formulas. Okay, so sine of 2 theta is 2 times sine of theta cosine of theta. So it might be helpful to have this written down. We have cosine of theta, it's negative 5/13. Sine of theta, opposite over hypotenuse, would be 12/13. So maybe that would be helpful to have written down. Regular sine is 12/13. So when I do sine of 2 theta, the formula from up top there is 2 times sine times cosine. Sine was 12/13. Cosine was negative 5/13. And that would be negative 60 times 2, negative 120 over 169. Okay, can be helpful with a calculator. 2 times 12/13 times negative 5/13. Math, frac, negative 120 over 169. Maybe you did it with the fraction button. 2 times it's alpha, y equals. It gets me to this shortcut menu, and then it's the n over d. And you can do the 12/13 that way. And then usually if you type it in as a fraction, it gives you the answer back as a fraction. Yep. All right. And that way it also tells you if it's the most reduced or not. Okay, so there we go. Cosine of 2 theta. Okay. You know, I'm fine with the cosine squared minus sine squared one. All right, cosine is negative 5/13, so negative 5/13 squared minus 12/13 squared. Okay, negative 5 squared is positive 25 over 169 minus 144 over 169. 25 minus 144 is a negative 119 over 169. And that should not reduce. I'm pretty sure 119 is prime. Okay, now for the fun ones. And by the fun ones, I mean there's a lot more work. The half angle ones are always going to be a little bit more work because they involve a square root. Okay, and also the half angle ones you have to think of a little bit. Okay, so if I am between pi, and this might be easier to think of it in degrees. If I'm between 90 and 180, and I cut those in half, and actually it's between, so not even less than or equal to, just less thans. Now I'm down to 45 and 90. So between 45 and 90 degrees over here, after I cut this in half, everything should be positive. Okay, so you get whatever frame, whatever quadrant you're in, take those and divide them by 2 when you cut these in half. And that's going to give you a hint as to what this is positive or negative. So we are in quadrant 2. That was 90 to 180. I cut that in half. 45 to 90. Okay, that should mean that we should be expecting positive answers because this is part of quadrant 1 where they're both positive. So positive answers here. We won't need the negative in front. Sine of theta over 2 equals, okay, we're not going to do the plus minus because we already know it's positive. Square root 1 minus cosine over 2. Well, minus cosine, well, my cosine was negative 5/13. 1 square root. 1 minus negative 5/13 over 2. And my 1, I'm going to change to 13/13 so that it works better here. 13 minus negative, so actually plus 8, is going to be 18/13 over 2. And I got to do a better job of this. I'm terrible at that, letting that 2 slip outside of the square root. Okay, so 18/13 divided by 2. Same thing as divide by 2 is multiplying by a half. All right. And then the 18 and the 2 cancel out. We have a 9 on top. So we got the square root of 9/13. See how much fun this is? The square root of 9 is 3 over radical 13. Fix your denominator. We got 3 radical 13 over 13. And it's positive because after we cut our angles in half, we're going to end up in quadrant 1. Whew! All right, I'm out of space. I'm going to slide over to a piece of paper here for the cosine one. We'll keep this off to the side. Cosine of theta over 2. Your formula there, plus minus, okay, we said after we cut it in half, we're between 90 and 45, so that's going to be quadrant 1, so it's the positive one. Square root 1 plus cosine over 2. Only difference between the sine one and the cosine one is this is a plus now. Okay. 1 plus negative 5/13 over 2. Do my same thing here. Change that 1 to a 13/13. 13 plus a negative 5. We're going to have 8/13 over 2. Instead of dividing by 2, we're going to multiply by a half. And that'll be 4 on the top over 13. We can do the square root of 4, it's 2. I can't do the square root of 13. I also don't want a square root of 13 on the bottom of my final answer. Two radical 13 over regular 13. And again, I knew it was the positive one because we were in quadrant 2 between 90 and 180. And if you're cutting those angles in half because we're doing a half theta, then we would be between 45 and 90, and that would be positive for sine and for cosine. All right, so a lot of fun there when you have to do all 4. Most of the time, if you have to do all 4, in like the book, I'll try to cut those down to do double angles on this one, do half angles on that one, kind of a deal. Okay, let's just do that. Let's do the double angles for this next one, for B. We'll do double angles here for B. So I'll get you started, and then we'll push pause, and then you can finish them out. So, again, we're between 90 and 180. Sine is 4/5, so we're in quadrant 2. So draw your triangle in quadrant 2. Okay, your corner should be coming out of the origin, and your right angle should be not by the origin, over here on the outside, on the x-axis. Okay, so sine is opposite over hypotenuse. Okay, this is a 3, 4, 5 right triangle, and because we're in quadrant 2, I'm going to put a negative on the 3. 3, 4, 5 right triangle. If you didn't know that off the bat, you could do a squared plus b squared equals c squared. So sine is 4/5. It could be helpful to know what cosine is right away. Cosine is negative 3/5. And we're doing the double angles only because we don't have enough room. All right, so go ahead and push pause, and let's see what you can do for the double angles. All right, double angles. Sine of 2 theta equals 2 times sine of 1 theta, so 4/5, times the cosine, negative 3/5. And we're going to have negative 12 over 25 times 2 is negative 24 over 25. Okay, 4/5, negative 3/5, negative 12 25ths, times 2, it's 2 over 1, so the 2 is only going at the top of the fraction, negative 24 25ths. Cosine 2 theta. I'm a little partial to the cosine squared minus sine squared. You got to go in order, though. Cosine squared minus sine squared. 9/25 minus 16/25, negative 7/25, and we can't reduce. Done. We're going to save C for tomorrow for day 2 notes. Let's drop on down here to D cosine 3/5. Okay. And we're going to do the half angles. All right. So pay attention to where we're at. Between 270 and 360, that's quadrant 4. And cosine's 3/5. Okay, so that means adjacent is positive 3. Hypotenuse is 5. And if we're in quadrant, this is another 3, 4, 5, but we're down 4, so I'm going to put the negative 4 there. I like to put the negatives on my drawings of the triangle. That way I don't forget. Okay. Half angles. Sine of theta over 2 equals, okay, so let's see here. If I cut this in half, that's 135 to 180. If I cut this in half, 135 to 180 is going to put me, all right, right up here. And that means sine is going to be positive, but cosine is going to be negative. So be careful there. Sine is going to be positive, cosine is going to be negative. So the sine one's going to be coming out positive. Here we go. Big square root. We got 1 minus cosine, 3/5, over 2. Okay, change your 1 to a 5/5. So we got 5/5 minus 3/5. Big square root of 2/5 over 2. Well, 2/5 divided by 2. Maybe we can see that's going to be 1/5. If not, divide by 2 means multiply by 1/2. And then the 2's would cancel out and we'd have the square root of 1/5. Square root of 1 is 1. Square root of 5 you can't do. Don't want to stop with a radical on the bottom. So we end up with radical 5 over 5. And we said it was positive because if we cut this in half, we end up at 135 to 180, which is over here in quadrant 2. So the sine would still be positive, cosine is going to be negative. Okay, cosine is going to be negative, so let's keep that in mind for this one. Cosine theta over 2 equals, big square root, 1 plus 3/5 over 2. Okay, so 5/5 plus 3/5 is 8/5 over 2. Instead of over 2, dividing by 2 is multiply by 1/2. You could go with 8/10 if you wanted to and then reduce to 4/5, or you could do, this cancels down to 4. So we got the square root of 4/5. Don't forget we're in the negative because we're in quadrant 2. For cosine is negative in quadrant 2. You can do the square root of 4. It's 2. Can't do the square root of 5. Fix your denominator. Negative 2 radical 5 over 5. Okay, again, don't forget this one's negative because after cutting these angles in half, we're down to 135 over 1 to 180, which means we're here, which would mean our cosine would be negative and sine would be positive. 1, 2, 3. We got one more problem to do. How are we doing on time? 19 minutes, a little bit of a longer video. But this is some tough stuff. Okay. Now this is giving me the tangent. Let's see here. So I guess we can work on 2 things. Number 1, we're going to work on drawing the triangle from tangent. And once you have the triangle drawn, then you should be able to figure out what sine and cosine both are. But we're going to also do the tangent formulas for this. I think the actual directions would have said find sine 2 theta, cosine 2 theta, sine theta over 2, cosine theta over 2. But we haven't done any tangent ones, so we're just going to try it from here. The tangent ones get a little messy, but we'll be okay. All right, so we are 90 to 180. So we're over here in quadrant 2 again. Now tangent equals negative 8/15. Remember what tangent is? Opposite over adjacent. So opposite 8/15 is adjacent. Which one's negative? The 8 is going up vertically, so that's positive. 15 is going to the left horizontally, so that's going to be my negative. Okay? And now I'm going to do a little a squared plus b squared equals c squared to figure out that this is 17. Uh, 225, 289, 17. Okay? So from there, opposite over hypotenuse, sine is 8/17. Cosine adjacent over hypotenuse, negative 15/17. Okay? So if they gave you tangent, that's opposite over adjacent. If it's negative, you're going to have to think a little bit. You know, what if it was quadrant 3? This would look positive, but both parts would be negative then. So you got to think a little bit. And then you should be able to should be able to get your triangle drawn and come up with what these other two things are. Because the double and half angle things all rely on sine and cosine. Okay, the tangent ones are a little bit weirder. We're going to try those because we haven't practiced those yet today. Tangent of 2 theta equals 2 times tangent theta over 1 minus tangent squared. Okay, so we have on the top 2 times negative 8/15 over 1 minus negative 8/15 squared. 2 times negative 8/15 is going to be negative 16/15 over. Okay, so I'm going to leave this 1. We'll come back to this 1. Negative 8/15 squared is positive 64 over 225. Okay, so by doing this first and seeing that it's over 225, now I know what to change my 1 to be. It's 225. 225 over 225, and we still have this minus in the middle. Negative 16/15 over 225 minus 64 is 161 over 225. Fraction over fraction, multiply by the reciprocal. Okay, now if you used your fraction key, it would reduce it for you here, but we can use our brain. It's negative 16 and 161, they look alike, but you can't reduce. 225 and 15, yep, because 225 is 15 squared. So negative 16 times 15 over 1 times 161. And we're going to finish with a negative 240 over 161. Holy moly. To stay up with all that, we got 1 more to go. We're going to do the half angle. All right, if we cut 90 and 180 in half, we're down to 45 to 90. That's quadrant 1, sine positive, cosine positive, tangents positive. Nothing to worry about. Tangent of theta over 2 from the front of our sheet here is 1 minus cosine over 1 plus cosine. Big square root over all of that. Okay, so it helps that I know what my cosine is. It's negative 15 over 7. No. Yes? Yes. So we're going to have cosine is going to be negative 15 over 17. Opposite over adjacent. All right, sine over cosine. So we have cosine is negative 15 over 17. One minus negative 15 over 17 over 1 plus negative 15 over 17. Okay. So we're going to change our 1s to 17s over 17s. And I'm going to lose the square root for a second. Otherwise, well, I should probably do better than that. We'll do a big square root here. So we're going to have 17 over 17 minus a negative is going to be a plus 15 over 17. 17 over 17 plus a negative is a minus. Okay, so we're going to have 32 over 17 over 2 over, oh wow, this is going to be nice. They don't always work out this nice, okay? They don't always work out this nice. Flip it, multiply, we got 17 over 2. 17s cancel out, 32 over 2 is 16. And this is going to be 4. Wow. Interesting. All right, that is not the answer I got the first time when I did this problem. So I either did a nice little mistake over here, it worked out perfect, or I flip-flopped something on the other one. But if you got 4 and that all makes sense to you, fantastic. It doesn't always work out that way. You're probably going to get something with a radical left over at the end, and we'll be okay because we know what to do with that, just like you did in your other ones. Do what you can do a square root of and fix the denominator. All right, folks, what do you have for today then? Day 4, 13.4, day 1. Looks like we got page 897, 13 to 16, 31 through 33. All right, 13 through 16, that's 13, 14, 15, 16. That's 4 problems. Okay, that's going to say to do all 4, half angles and double angles. All right, I don't care which 2 you do. You don't have to do all 4 there. You can do double angles on one, half angles on the next. All right. Thanks for watching, and we'll answer any questions for you tomorrow.